Right? So, I mean, what we are trying to build is actually not a monitoring system. What we are trying to build is a platform that's doing real-time analysis of how your workloads are consuming the resources on the infrastructure. And the reason we want to do it in real time is because we potentially want to change the behavior of the infrastructure based on the demands of the workload, right? And so what we're going to show you next essentially is how we can consume these analytics to orchestrate virtual machines that are running on your infrastructure to auto-migrate them from nodes on which you could have hotspots.
When you say migrating virtual machines, that's sort of like a VMware vMotion kind of thing. Can you do the same for containers where potentially you would kill them and respawn them? Is that something you would be looking at in a similar thing?
Yes.
Okay.
So it's the principles are exactly the same. I mean, the whole idea there. So here we've kind of integrated. We're showing you the integration with OpenStack. The kind of the mapping is there's a project and there's instances inside the project which are virtual machines. In the case of Kubernetes, there's pods and there's containers. But the principle is exactly the same. But there, what we orchestrate is pods. We map pods to hosts and spin them up, or
because we don't want to come away thinking, this is a monitoring solution just for VMs. Okay, you have deep analytics, that's sort of cool, but definitely the container thing is something new. Containers on OpenStack, on KVM, and doing deep analytics for that is also something different that sets you apart from being just another VM monitoring.
And that's what we want to get to. So just to give you a little history of the company. So initially, when we developed our software, we jumped straight to orchestration. We jumped straight to control, right? And what we were really doing was controlling how your apps get mapped to your resources, like how you would place pods on or containers on a host when you kill them and you spin them up. Same for VMs. But then when we went to market, what we found was that the customers really weren't there yet. Right? They still wanted to be able to see what's going on before they would say, hey, I'm willing to give up complete control to your orchestration. So we kind of took a few steps back and built out this entire monitoring experience. Right? So and the way it plays out now is that monitoring is something that enables you to kind of after the fact figure out what happened. But really what our goal is to run all the analysis in real time and orchestrate based on the results of that analysis, and orchestrate both VMs and containers, right? Because really for all of our customers, they see both of these environments coexisting for a while to come. It's not an either or thing, it's really they want to do it to both.
So is that also where you see then your integration with Mesos and Kubernetes? For example, your analytics will see that a web service is being overhit and there are 10 web servers in the pool, or 10, let's not call it web servers because that just gets boring because all containers seem to do web services easily, but an application server is now running out of resources. Yep. Your then AppFormix would then do the deep packet inspection or the analytics, discover what's wrong, and then work out, I need another 5 containers spun up on these kind of hosts to be able to alleviate that kind of load. And because containers are really quick to spin up, this isn't every 5 minutes I'm looking and going, okay, let's expand the cluster. You can literally do it within a second and off you can go, and not have that 5 minutes of your app being slow, but really quickly be able to spin up containers and I suppose VMs as well.
Absolutely. Okay. And that really goes back to why we did the agent all on our own, right? Eventually, through our agent, we can also issue commands on the host. You spin up the containers.
So then that's not necessarily talking through Kubernetes or Mesos, but doing any host-based action, for example.
Yes.
Okay. And would that be a predictive?
Containers have special requirements? Do they have to be all be same installation or?
So, in the world we live in, any successful system provides a good API for the system to be extensible, right? Whether you look at Kubernetes, you look at Docker, you look at OpenStack, there's a very rich set of APIs that surrounds the system that you can use, and that's where we integrate. I mean, so following this demo, I'm going to show you the next one where we can actually configure that endpoint and issue the calls.
So let me quickly go over this demo. So we have the same system in which we did the installation. We have two compute hosts, AS94 and AS97. And what we are going to do now is that when the health of the system, when we detect that the health of the system is going bad on one of the compute hosts, we will go ahead and take the liberty to migrate all of the instances from this compute host to a one where the health of the system is doing good. So what we are going to see right now is that the health of the system deteriorating, and which will just pop up here in a second. So as we see here, the health of the system has gone bad, and so we can now log on to the machine, and we can see that we had 3 instances over there, and all of them are migrating. So it's like instance. As soon as we detected on the sub-second granularity, we are able to figure out that, hey, something has gone wrong with this, and so before this server kind of shuts down, I need to somehow migrate my workload. And so this will cause all the VMs to get migrated back. I think it will take a couple of minutes to migrate. And all of this is using standard APIs, as Sunit was mentioning. We don't go ahead and modify any of your OpenStack. Like, there's no code modification in OpenStack at all to do this, right? So we just go in and install and make sure your existing OpenStack environment works with it.
So what if then your network's contention on that host, and if you're going to basically do a migration from that host, you're going to add more contention to that host, aren't you? Yeah. So how do you counteract that then from a networking point of view?
Then you'd have a differentiated policy for that.
Yeah.
I mean, so in this case,
yeah.
I mean, it's this is what we've realized, right? What we've realized is that when we go to customers, we see a large pool of OpenStack users who've predominantly been using VMware for most of their lives, and now they're using OpenStack. Mm-hmm. And they're used to a certain way of managing their VMware infrastructure, and there's not a parallel set of tools available for managing their OpenStack infrastructure. I mean, there's a lot of APIs in OpenStack that let you configure everything, but then you have to do the work. And what we've done really then is taken many of those experiences that are important for them and build them on top of OpenStack as well. Mm-hmm. So this is one of them.
And so right now, as you can see that there were 3 instances running on AS97. Now 2 have migrated to AS94, and they instantly show up on your dashboard as well. So it just happened behind the covers. You didn't have to do anything, no manual configuration. We did everything behind the hood. We detected the problem. We auto-fixed it for you. Mm-hmm. So this is the self-service IT model that we want our operators to have. And so they don't need to get any PagerDuty phone calls, basically.
Yeah. So this is essentially vMotion for OpenStack, mm-hmm. in a way, what you're doing here. But OpenStack, I mean, the model of moving VMware to OpenStack, and sort of operating the same way is probably something people are comfortable with. But in the whole pets cattle kind of model, if you're running applications that need to scale out, scale up, whatever, and you don't necessarily need to track state, will your system actually, I guess, grow, the existing deployment? So you're basically going to say, like, look, I've got a whole stack over here of a database, a front end, a whatever, right? Proxies, all that kind of stuff. Can you start spinning up workloads where you don't need to create, track state and actually do all that?
That's our next demo. Thank you for pitching it to us.
Okay. So while we move on to that demo, can you give us an idea of your scale at the moment? So how many agents are you collecting data from at the moment out in your customer base?
So the first thing to keep in mind is that we as a company don't collect any data from our customers. They own all of their data. It's running on-prem. And we are in deployments which go from, let's say, hundreds of nodes to thousands of nodes.
Okay.
Yeah, I think our smallest production deployment is 60 nodes.
60.
60.
Yeah.
This.
Let me just quickly introduce it. We are out of time. So the previous capability was, hey, if we notice that there's something is at risk or unhealthy in your infrastructure, then we are able to move workloads away from that host. But really, if we start to look at cloud native applications, it becomes more about horizontally scaling your application, right? So you want to be able to monitor in real time how the application is performing, if the infrastructure is giving enough resources to the application, and if the application is not getting enough, you want to be able to kind of scale up or scale down the resource to the application. So that's what this is. Parantab's going to set up a rule. In this case, what we've done is we've left the system to be completely extensible. So if you're working in some kind of DevOps model, you can come in, you can set the rule up, and you set it up in a way where if at any time across all of your resources, across the aggregate pool of resources, we notice patterns, as in you're not servicing enough requests or your CPU is overloaded in all of your instances and things like that, then we automatically make the call to your application orchestrator and give it sufficient information for it to scale up or scale down the resources, right? Now, the reason we are not doing the scale up and scale down ourselves is because we want the system to be extensible. We want it to be in a way where you control the action and we give you the ability to supply the action.
So like distributed applications have the same kind of metrics that they push out on this message bus and that get consumed as an instance or a VM or a host is generating and pushing out on the message bus. So this capability is allowing aggregates of that, so aggregates of instances in a project or applications in a project to configure a threshold for a metric. So like when 80% of my instances in a project called Kubernetes deployment have average CPU usage over 80%, I'm going to generate a message which is going to be handled by this endpoint, which is pluggable. So you write your own application, you understand how to load balance it. So I have an HA proxy layer which I know how to load balance, which is serving requests to a sharded MongoDB. So I know how and where I want to add a new Mongo node. So this action handler URL is acting as a proxy for that. So it's going to get a message from a system when this application is meeting this condition, when these many of instances in that project have metric above, and this metric is the same as what we allow event stream rules. And this period is configurable. You can put it as the last 10 hours or whatever, what have you. And so this metric goes in our system. We are monitoring the collection of, so it's like an app that's listening off of the message bus and accumulating and aggregating all the intelligence and generating a message to this URL. And this URL basically right now is printing out all the messages it's getting from us. We are kind of stressing the system, but it's actually denoting how extensible the actions can be. Like it's getting the full overview of what happened to its application and why it got triggered a scale up or a scale down notification. So based on that, it can add a VM to its Mongo DB layer, or it can, like, if it's not really using its MongoDB layer, like to the level that it expects, it can scale it down. It can take any action that it wants based on this rule.